Alright, I'm just going to get started then. I'll switch to YouTube next time. So I'll go ahead and explain my setup a little bit, just in case anyone's unfamiliar. So I'll be using Emacs as my editor. The project is already on GitHub, so I'll be pushing the commits when I can. And of course I have to use the Arduino IDE as the compiler, but I will not be using it as the editor. So just for compiling and loading to the Arduino, which is here, Arduino Uno, and the Nokia 5110 LCD. So you can see that there. Like I said, I'm going to start right from the beginning, so I haven't actually made any connections on the breadboard, except for bringing over the power lines to each other, just so I can use any of them if I so choose, which I will. So I guess the first thing is I'm going to hook up the LCD. Actually, first I'm going to get the sample code from the Arduino website. Just minimize this. So there is actually example code that someone else has written for this LCD, or for a similar LCD, the Nokia 3310, which uses the same driver. So I'm going to start with that example code, but probably not use it as is, because it may have some bugs or some things I'd like to change. So I'll just copy that. And here it is. And this also lets me know what the pinout is, at least for this example code, which I'll probably change the pinout as well, though I don't have to. That's actually not bad. So as you can see, these constants up here do actually refer to the pins on the LCD. And if anyone can, just let me know if the visual is not very good, and I can try to fix that as well. Try to make it big so that you could see the actual letters on the LCD when they show up. But yeah, just let me know. Actually, one thing I noticed is that reset and the CE pins are reversed in the code, just the ordering, whereas everything else is fine. I'm just going to switch those. And the pin numbers aren't really that important, because I can always change those up. But I'd like to make sure the LCD is working and understand how to initialize it and how to use it properly, software-wise. So I'm just going to start with that. So I'll be putting it in here. So that's rows 10 to 17. So I'll have to wire it up. Start with bringing over power and ground. That's 5V on the Arduino Uno. This power, ground is ground, obviously. And the rest. So the reset pin, which if I put it in this way, it's going to be pin 17. I'm not going to worry too much about the wiring, so the colors of the wire, or the prettiness of the wiring, I guess, because I can always fix that up later as well. And then, so that's SCE, goes to pin 7 on the Arduino. We'll just sort of alternate white and yellow. And then DC goes to pin 5. Would make sense if these were actually in order. So I'll probably end up changing that. SDN, pin 4. and S clock, pin 3. And next on the LCD, after S clock is VCC, and then light, and then ground. So VCC is obvious. Light is actually to control the light on the LCD. I don't know if I would call it a backlight. I guess it sort of is a backlight, but the lighting kind of comes out the sides a little bit, as you'll see. I'm just going to use pin 9 because it does have to have, it has to be a PWM pin so that I can make it different brightnesses as opposed to just on or off. And finally ground. So that looks good. I'll just make sure the camera angle is showing. Yep. And get this in there. Okay. And I can plug in the Arduino. Oh, and it's running my code from before. I forgot about that. So I have already tested this LCD just to make sure it works. So I'll just save this. And there's an encoding error. Oh, right, because those two characters are not ASCII. Let me just go change those. That's a left arrow, and right arrow. Now it saves fine. Make sure this code compiles, and it does, and upload it to the Arduino. So hopefully you can see that. It is showing something on the screen, but as you can see, the contrast is kind of weird. So let's look at the initialization routine. Initialize is spelled a little weird. I would use a Z. So I also have the data sheet here, so I can also reference that. And I have used this sort of LCD before, so I do have some experience with this. And by the way, if anyone is unfamiliar with LCDs in general, this is a graphic LCD as opposed to a character LCD. So it doesn't actually have characters in its memory, so you have to make each one your own, essentially pixel by pixel. So that's why this code, these are actually all the characters that are made. They're mostly, most of the ASCII characters, some others too. It's just whatever this guy chose to have in his library. So even if I were to write this code on my own, this part would all be the exact same. So there's really no point in doing that myself. So I will keep this part of the code, although I may, I probably will change most of the rest. Yeah, that doesn't need to be there. So for the initialization, that's basically to start up the LCD in a way so that when we use it, it works as we would like it to. And the pin modes are just obviously to set the pins as outputs, and the actual for this LCD there isn't a specific initialization routine that should be followed. There's only the reset that has to be done. So a reset pulse must be applied. Hopefully you can read that, it's not too small. There it is. And then once the pulse is applied, then this reset function occurs and everything is basically set to the default values, and then we can go ahead and use our other functions. Which are actually before this. So here's the function table. So if we look back in the code, let me just bring this over here, and so the first function that's happening here is this one, the function set. Actually, to make this more obvious, I'll show it with the calculator. So this hexadecimal 21 shows that this bit is set as well as this 1 bit, or I guess the 0 bit. So that's the function set extended instruction set, because that's what this H refers to at the bit 0. So it's either use basic instruction set or use extended instruction set, and that's just here. So if H is 0, you're using these functions next. If H is 1, then it's these functions. So the next functions will be the extended functions in here. So set LCD V op, operating voltage for the contrast. So that is what I'm going to want to change so that the hello world looks a lot better, because right now it looks awful. And the temperature coefficient, that's fine. Bias mode, so that's actually a good bias mode for this LCD. Could make it higher multiplexing, but that could lose, it could make it look a bit worse, so I'll leave that. And then this is just switching back to the basic commands. So again, it's so that's hexadecimal 20. So it's it's the same thing, but just without that 1 bit set. So H is now low, which means use these functions. So then the last one is hexadecimal C, which is this one here. So the display control, where D is high, this has to be 0, and E is 0. So that means normal mode. And that sounds like a good mode to use. So I'll change the contrast. So I have fiddled around with this a bit before. It turns out these LCDs are actually recycled. So they're actually from the old Nokia phones. So even when you buy them, on the PCB, I mean, they're already soldered on the PCB, but the LCDs themselves may have some scratches, and some may not even work properly, or may have some dead pixels or some on pixels or something. And also the contrasts are different, so each one will probably need a different value for this contrast to look perfect. So you basically just have to play around with it a bit. So this is B1 right now. I'll try A1. Not sure which direction to go. I think this is right. And I can upload that. And already it looks better. Yeah, that actually looks really good. So I might just leave it at A1. And again, I can change that later anyway. Wow, 47 people. Okay. So for now I'm going to leave the contrast as it is. Don't know why these comments are here. Bias mode. So if I look in the data sheet, let me just make sure this bias mode is what it says it is. So that should be 1, so 14, so that would be 1, 0, 0. So BS2 would be 1, BS1 is 0, and BS0 would be 0. So 1, 0, 0, that's 3. Whereas it looks like they intended to do this, which would make it 3. I mean, this number would be 3. So 1, 3 instead of 1, 4. So that's probably the reason for this comment. So I should actually change that to 1, 3. And make sure it still looks okay. probably won't make a difference. Oh, it did make a difference. I'll try changing the contrast again. And upload that. Oh, that actually looks a lot better. Huh, okay. Well, there we go. So the contrast was actually right. The bias mode was wrong. This person likes periods after their comments. So good, the LCD is working, and I can write strings to it. Let me just change something that's bugging me, just the formatting of this, real quick. Let's change that. And that. Yeah, so that's just going to look a bit better. I am using a proportional font for my coding. It's just a personal choice. Yeah, so that's better. Actually, I forgot slashes. All right. So let's look a bit more at this code. Since it's not my code, I should fully understand it and make sure it works as I expect it to. So the pin mode, that's all fine. Digital write, that's basic Arduino functions, so we know that's fine. And then LCD writing, so this function just writes either data or a command to the LCD, hence this DC, where up here, LCD C, this constant, well, it's just low where D is high, and this will make more sense in the data sheet. And so in this function, it's either passing LCD C for a command or LCD D for data. And the reason for that is back in this function table, or instruction table I should say, because it's either data or a command. So if it's a command, then that bit is 0, and if it's data, that bit is 1. So that's pretty straightforward. So let's see, right. So that's all fine. Yeah. And this is also how the commands and the data are actually written to the LCD. Should be some timing diagrams. There we go. Transmission of 1 byte or several bytes. So the SCE must be low during the transmission. Of course, S clock is pulsed. And obviously it's written properly because we can see hello world on the LCD. So I don't have to worry about that. That's good. And I am going to be moving this into its own library as opposed to having it in the main file, which in this case is the INO file. That's just sort of how Arduino works. Initialize clear hello world. So let's see what the clear does. So clear, I mean, I expected to just clear the LCD screen. I'll also write some comments in this code so that it actually has comments, because LCD clear could really do anything. I mean, it's a pretty good function name, but it should have at least a little description. So just go through the entire LCD. So LCD X and LCD Y. Right, so that's the width and the height. And then over 8, because each byte actually controls 8 pixels vertically, and index increases. So it's just basically setting every pixel on the LCD to be off, hence this 0. Now the problem I see here is that after the clear we can write hello world, but if we did another clear after this, it would just go from the point that it's at and clear everything afterwards. So I don't think the clear actually works properly. We can try it. Just grab it from here. I'll put a short delay of 1 second. Okay, so it does clear. Oh, right, because it would wrap around. However, if after this clear I put another string, such as test1, I guess. I'll just put test. And then run this. So what we'd like it to do is say hello world, and then be replaced by test at the top, but it's not at the top because the actual position for where it's going to start writing the text is actually after where it finished hello world, because it clears the whole LCD and then wraps back around. So the clear, I mean, this means either the clear or the LCD string function doesn't work properly, because one of them should set it back to the beginning, or the LCD string function should make it write to a specific spot that we can pass as an argument. Actually, I'm noticing something else. The characters are 5 pixels wide, but there's 2 spacings between them, and that's really just taking up space that doesn't need to be there. So I can get rid of one of these, either before or after. Should do before or after, which would make more sense. I guess before. Yeah, sure. So if I do this, then we should see hello world. Well, we can see how it looks. Yeah, so it still looks good. It just takes up a lot less horizontal space, which saves space. And since this will be a text adventure, we probably want to put a fair bit of text on it. So it's good to have it a little bit squished. If I were to get rid of both of those, then the characters would be merged together, so I'm not going to do that. It is visually better to have a space between each character. So maybe for the clear, I'm going to make it start at the beginning and then clear to the end. Yeah. So let me go to the function, the instruction set, and I want to set the Y and the X address both to 0. And I'll do that before it actually clears. I'll fix up the formatting at some point too, just so it matches the formatting that I'm used to, which is not that. Sure, not like that. I won't worry too much about that right now. And the function names. Anyway, so this, let's bring this over there. So I need LCD write, and this is a command, so LCD C, and the command in this case, I'll just show here so it's more obvious. So I'll just start with the y address. Doesn't matter if I do x or y first. And I will actually make this into its own function as well, because this may be quite useful to set the position. Actually, I'm sure it will be useful. So that's 4, 5, 6. Sorry, 3, 4, 5, 6. So hexadecimal 40. And the next one should be 80. If that's right, yep. So that should set it to the top left of the LCD, because that's where 0, 0 is, as you would probably assume. Yeah, so now if we do this hello world and then write test afterwards, it should write test in the same spot that it started with hello world. So let's try that out. Perfect. Okay, so I probably should make a function out of that. Still don't know where I want to use it. I mean, I guess it should definitely be in clear. Yeah, actually first I'm going to change these to enums, because enums are actually safer and have a name in the compiler. So for debugging it's actually better, and it's nice to group them, just better for a lot of reasons. So it's kind of more of a formatting thing, but I'll just do it real quick. Call these pins, and I guess I can do it here. So those, and this is just, I may change how this works too. It's pretty good for now though, so I'll leave this as it is. Use tabs here. Oh no, it's spaces. Oh man. Okay. So that's better. Okay. And this is actually the max x and max y. That may not really be clear. Yeah. Okay, so that's looking good. Let's change that. Oh, right, there's only one place. Good. It's always better to be explicit than implicit. So put some brackets around that. Okay, and so I'm going to make a function out of the positioning. I might as well start moving this to its own library actually, before I make my first commit. Yeah, so I'm going to do that. So this will be Nokia 10. better. Get rid of that for now. Safe. Why is this highlighter not working right? Oh no, that is right. Okay, so that's all good. And the function names. I can actually just, yeah, I'm just going to change this file's name. This is the Nokia library now. Can get rid of setup and loop. Yeah, I guess I should leave this in the source file, so that it's not used by any other files accidentally. And while I'm at it, I'm just going to change the names of these functions. I'm just going to fix up this code a bit now, just so that I don't have to go back to it later. I apologize if this is sort of boring. Just make sure I'm not missing any chat, actually. Okay, no chat. If it was on YouTube, there'd probably be more chat. Alright. That's fine for now. Spelling that with a Z. Highlighting screwed up a little bit. Let's reload the file. Oh, okay. Oh, I guess it doesn't recognize byte for some reason. That's fine. Okay, so that's good. And I'll add some comments before I forget. So this is the actual characters. Shouldn't be anything I have to include here. Just trying to think. No. I will have to in the INO, obviously. I'll have to include this library. I could even put this in its own file. It's just so big. I'll leave it here for now. Alright, so I'll just say, that's fine. And this just writes one character. Yeah. Cursor 0, 0. Click on the cursor. This is the address. Yeah, it's like a cursor though. It actually is called a cursor on other LCDs anyway. Okay. And I'm going to change how the cursor moves. Just make sure I haven't. Oh, right. Forget that for now. There it was. Anyway, so initialize this. Oh right, I'm actually going to put the pins in a different file because that's specific to the hardware, and if I want to make any hardware changes, that should be in its own library. So that's often called the hardware abstraction layer. So that's HAL, yeah, HAL, like in 2001: A Space Odyssey. Just a coincidence. So the pins should be there, as well as pin modes. Yeah. This is just initialize the LCD. It's bad to have magic numbers, so I will change those as well. Let me just finish commenting the functions. And yeah. Actually send a command or data to the LCD. Yeah. Okay. So I'm also going to need HAL.h. And this is going to be, yeah, I can put all the pins here. Probably should have done that with the macro. That's fast enough. So, and for the buttons, I'll put them here eventually. So I'm not going to add the buttons till I have the LCD all working as I'd like it to. The buttons are pretty easy to add anyway. So that's good for now. Well, actually, not quite yet. So I have HAL and initialize should actually, well, all of this should really be in the main file anyway. So this can all be gone. So mode. Oh, right. So this will be set up pins. Let's sounds fine for now. This is all going to change. Loop is fine. Nothing in it yet. And it's going to have oh wait, no, that should actually be in, I'll put that in the main file for now. There we go. Oh, right. Sorry, I typed too fast for you, Emacs. Jeez. I'll just change that real quick. Okay. So set up pins. Perfect. So, where was I? So those are going to change, but I'll leave it for now. I mean, I really only have to do this once anyway, so I could leave them as magic numbers for now. And a magic number, for those unfamiliar, is just when you have a constant like this. It's called a magic number because when you look back at it, it's just kind of this number that appears out of nowhere and you have no idea what it means. So you would have to go and reference something else. It's just kind of magical. So it's nice to actually give that a name, like have it as a constant with a name, and then use that name. Anyway, I'll leave it for now, because it's only happening once, like I said. Change these are now lowercase. That's a Z. And, okay. Right. So those are all good again. Let's see if it compiles or if I missed something. Probably missed something. Why? Oh, I hope this doesn't. Looks like you may have to have a C++ extension for the file name. Let's see. Okay, so there's the problem. Oh, wow. So the file name needs a C++ extension. Apparently you can get around that. Well, I'll try to fix that another time. For now, I'll just leave it as a C++ extension. Let's delete the other file. Okay, so now it's working. Let me just re-upload it. Make sure the program still runs properly. Hello world, test. Perfect. So this is a pretty good starting point. I should also, oops. Should commit this to the Git. should actually track all of them. Oh, wait a minute. Tracking. Oops. What's that command? Oh, right. It's just not all. That's. Oops. I want to make sure these are all staged. Yep. Okay, so this is first commit. Well, actually no, this isn't the first commit. But this is the first working demo. So I mean, it's not a demo of the text adventure, but the LCD demo, I guess. Yeah. Okay. And I'm just gonna push that too. Okay. Great. So it seems like a pretty good place to stop for now. It's only been an hour. Let's just see if anyone has anything else to say in chat. Does anyone have any questions or want me to keep going? And I guess by anyone, I mean that one person who's able to chat. I really gotta switch to YouTube. I'm gonna have to plan out the text adventure a bit too. But obviously writing text to the LCD is a big part of it, so I'll make sure all that functionality is there. Oh, okay, so that's a good place to stop for now. I can also make some notes actually, just before. So tasks. So what was I going to do? In here, I want to make a function to position the cursor. And for writing strings, I guess, I mean, I can either have as a part of the writing string function an argument that says where the string starts, or I can just call the function to position the cursor first and then write the string. But the string function only has the one argument right now, which is the string to be written. So I can actually give it another couple arguments for the position. Wouldn't be too bad. Or I can make another function, lcd string at position or something. So something about that. Add function to write string at a specified position. Actually, this file is not going to be tracked, but I do want it to be tracked. So let me move it there, and I'll rename it too. It is just a text file, by the way. It's just org mode in Emacs. So that's tasks. That's pretty good. What else? That's all I can think of right now. And then eventually I'll start making the map for the game and have sort of a it's going to have sort of a menu where pressing one button will scroll through the menu. Like, I'm thinking it'll probably just have 2 buttons, maybe more, it depends. But if it does only have 2, why is my video stopped? Well, anyway, if it does only have 2 buttons, then one button can scroll through the options and the other button can select an option. And the options are the actual gameplay. So if you were to walk to another room or attack something, I guess, or use an item, pick up an item. I'm also curious to see just how much I can put into this Arduino Uno before I run out of memory. Right now, the total memory used is about 2K out of 32K of flash memory. So still got a lot to go, a lot of memory to use. So yeah, I think I can make a pretty decent game out of this. Alright, so I'm just gonna track this. And what's this file called? I don't know. This file is going to be where I have all the issues and stuff. I'm not actually going to use GitHub for that. I'll just push this real quick, and that should be a good place to stop. I think I lost internet connection. Great. Well, that's fine.